Hi, I'm Mariko, one of the Forta core devs, and I work on enabling more data science and machine learning on the protocol. If you attended the community call 2 weeks ago, you may have noticed that there's a drop in the active agents count. 2 weeks ago, there were around 250 to 260 active agents, and today we just shared with you that there are 184 agents. The active agent count can fluctuate daily with new agent deployments, but the recent drop was the result of Forta disabling over 100 agents to improve the alert's quality. So today, I would like to tell you more about why Forta did that and give you some insight into the process we used. Recently, we noticed that Forta Explorer was becoming crowded with redundant alerts that were all reporting the same findings. When we investigated this, we found out that most of the alerts were copies or variations of the starter examples Forta provides in the documentation. For example, the most common alerts were high gas and transaction volume related. This was making alert discovery challenging for Explorer users and taking up scan node resources. So we had two goals. One, reduce the noise on Explorer, and two, free up resources on the scan nodes. So the challenge was identifying the redundant agents, and there were several ways to do this. One option was finding exact or similar copies of agents by manually comparing one agent at a time. But as you can imagine, this would have been a time-consuming and error-prone task. Another option was creating a simple algorithm that calculates diffs between two agent codes. This approach would have challenges capturing agent codes that are not exactly identical, but very similar. For example, that could be slight code changes like an extra new line, a comment, or tabs versus spaces. Finally, we can use some basic techniques from machine learning which can help us extract insights and patterns from data. So with the help of data and ML techniques, we were able to find not only exact copies, but also similar agents to disable. So there are roughly 3 steps to apply some basic ML techniques to this problem. The goal was to find agents that were similar to the starter examples Forta provided. So I'll give you a quick overview of how this happened. The first step was to convert agent code into numbers. It's easier for computers to compare numbers than text, so we first converted the code into a numerical representation using term frequency. This is a commonly used technique in machine learning called bag of words to tokenize the text and count the occurrences of words in the code. After applying this technique, a piece of code gets converted into a matrix of numbers that represent the word counts in the code. Now that all the code is in a numerical representation, we then use cosine similarity to calculate a single number that represents similarity. Cosine similarity is a commonly used metric to measure the similarity between documents, text, and code. This is getting into a little bit of math, but the goal is to measure the cosine of the angle between two vectors projected in a multi-dimensional space. But zooming out, the main idea here is that the more similar agents are, the closer they will be together, and the more unique and different the agents are, they will be further apart. Now, with one number to describe the similarity, it makes it really easy to decide which ones to disable. For example, we can confidently disable agents that have a similarity score of 1. But this approach obviously isn't going to be perfect. It can still introduce false positives. For example, there was a chance of disabling an agent that shouldn't have been disabled. So for lower similarity scores, we did several sanity checks. First, we reviewed agent code diffs. We also used other data signals. For example, we made sure there were no subscriptions tied to an agent, and the agents were at least 7 days old to allow developers to validate the deployment and explore the alerts. In the end, Forta found 53 exact copies of the Forta example agents and 91 similar ones. The 91 similar ones appear to fall into 4 major categories. Some had very small threshold or large threshold for gas-related alerts. Others had removed or added a comment in the code. Many had a minor difference in how the JavaScript code was transpiled, so there were no logic changes for these. So after disabling, we no longer see a flood of alerts from example agents on Explorer. We are also now able to surface more alerts on Explorer that are likely protecting projects and protocols. As for what's next, Forta will continue to see example agents getting deployed on a network, and we don't want to discourage that. Deploying an example agent is a great way to learn firsthand, so we want to encourage everyone to test that out. We will continue to disable redundant agents until we introduce and align network incentives in the future. And we're hoping Forta users will eventually become incentivized to self-prune test agents and continue to introduce useful agents. So that was just one example of Forta using some basic ML techniques to reduce noise and free up scan node resources. But as the protocol and its open data grows over time, we'll find more powerful applications to protect the open economy. One of Forta's goals is to build tools to enable the community to extract insights from alerts and detect exploits before they happen. Currently, the core dev team is working on getting the community access to alerts data. So if you'd like to learn more, please check out the Forta SDK documentation. Forta recently added a page on data science and machine learning for the community. And if there's anything Forta can improve to help you get involved, please don't hesitate to reach out. Thank you.